In this question, we're told that the probability that a certain rose bush will exceed 2 meters in height is 0.25. 60 of these rose bushes have been planted, and we're asked to use a suitable approximation to find the probability that more than 13 but no more than 18 of these bushes will exceed that height. Okay, so we've been told to use an approximation, which gives us a clue that we're starting with the binomial, but I knew before then, because we're told the probability, 0.25, which I'll assume is a fixed probability for that type of rosebush, and we're told the number of trials, the number of attempts, the number of bushes to be 60. So straight away I can say that this distribution is going to be a binomial distribution. I'll call it R. So R follows a binomial distribution of 60 and 0.25. I'm going to approximate, so I need to find the expectation and the variance. Expectation is NP. In this case, we get 15. The variance is NPQ, so I've already got my 15 for NP. I'll multiply that by Q, which is 0.75. 15 times 0.75 gets us 11.25. Okay, so that's enough for me to specify the normal distribution. X is going to follow a normal, where the mean is 15, and the standard deviation is root 11.25. And I'm going to write it in the form root 11.25 squared. Okay, the probability we've been given in the question is that it's more than 13, but no more than 18. I can rewrite that to use equals to symbols, and we get probability 14 to 18 inclusive, including those two numbers. And that sets us up for the continuity correction correctly. To make sure that I include 14, I'll start from 13.5, and to make sure I include 18, I'll go all the way up to 18.5. I should have actually used the variable R on the left hand side, but the color coding hopefully helps you keep track of what's going on. Okay, so let's see what this looks like on a diagram. Here's my normal distribution. The mean is 15. I'm going from 13.5 all the way up to 18.5. This is the area, this is the probability that we're looking for. This can be done in an NCD calculation, so straight to the calculator. Minimum of 13.5, maximum of 18.5, standard deviation and the mean, and from our calculators we get the answer 0.5243.